Hi, I'm Caden Slovacek, and today I'm going to be analyzing professional skateboarder Danny Wei's jump over the Great Wall of China. I'm going to start by playing the clip. The first thing I did was flip the image so that the skateboarder is moving from left to right, which is the way that I am used to looking at problems, and this doesn't change any of the information. Next, I assumed that we can treat the skateboarder as a particle for the calculations of this problem. This is reasonable because the skateboarder stays in roughly the same position throughout the entire flight. We can also recognize that this is projectile motion, which means the only acceleration acting on the system will be the acceleration due to gravity, which is constant. The goal is to find the initial velocity and the angle that the skateboarder launched at, which are two pieces of information that I could not find online. The first step in solving this problem is establishing an XY Cartesian coordinate system with an origin at point A, where the skateboarder launched from. You can then break the initial velocity into its X and Y components. From researching the gap, I've found that the change in X position is going to be 18.6 meters, while the change in Y position is 0 meters. We can also gather from the video that the time elapsed during his flight was 1.96 seconds. Since we know acceleration in this problem is constant, we can plug in all of the kinematic information we have gathered into the kinematic equations. This allows us to create two equations with two unknowns that are our target variables in this problem: VA, or the initial velocity, and theta, the angle that the skateboarder launched at. We can form a system with the two equations which allows us to solve for VA and theta, which was the goal of the problem. Theta ended up being 45.4 degrees, which makes sense because 45 degrees is the angle that maximizes a projectile's distance. And the initial velocity was 13.5 meters per second, which is about 30 miles per hour, so he was going very fast. From a real-world perspective, I found this problem very interesting because it takes you through the thought process one would take for designing a skateboarding ramp. And one day, as a civil engineer, that is exactly what I want to do.